Hi students, this is Vishwanath, chemistry faculty for NEET and IIT exams. See the next numerical, given Ka values of 5.76 into 10 power minus 10 and 4.8 into 10 power minus 10 for NH4 plus and HCN respectively. What is the equilibrium constant for the below reaction? So these Ka values are related to ion, NH4 ammonium ion, and HCN, it is a acid. From these Ka values we should calculate equilibrium constant for another reaction, that is see the next. So for this reaction we should calculate equilibrium constant. NH4 plus Cn minus gives rise to NH3 plus HCN. So see this, according to given data, ammonium ion dissociation NH4 plus gives rise to NH3 plus H plus. So acid dissociation constant Ka1 equal to 5.76 into 10 power minus 10. HCN, hydrogen cyanide, it is also a acid, it undergoes dissociation, then H plus Cl minus. Ionization constant for this HCN is Ka2 equal to 4.8 into 10 power minus 10. Now equation 1 minus 2, then we can get our required equation. See this subtraction, NH4 plus, and this is equation 1, this is equation 2. So second equation signs will be changed, then we can get this one, NH4 plus. This side Cn minus is negative, if we bring this side it becomes positive. This side HCN is negative, if we write this side it becomes positive. So finally required equation is NH4 plus Cn minus gives rise to NH3 plus HCN. So here this equation is obtained by subtraction of these two equations. So the equilibrium constant for this reaction is obtained by dividing respective equilibrium constants. That means Ka1 divided by Ka2, substitute these values, then we can get answer. So what is the option? Option B is the answer. Okay, so this is Ka1 value, this is Ka2. By doing calculation we can get this one. Option B is the answer. Okay, next, see the next topic, ionization of weak base. In previous classes we completed weak acid, now weak base. General formula for weak base, MOH equal to M plus OH minus, Kb equal to product of concentrations of these ions divided by concentration of the reactant. Here Kb means base ionization constant of weak base Kb. Same Kb we can write in terms of this one also, alpha, degree of ionization. So Kb equal to C alpha squared by 1 minus alpha. Here C equal to initial concentration of the base, alpha equal to degree of ionization. Okay, next, see this condition. If Kb is less, then basic nature is less, and vice versa. Kb value is less for a particular base, then its basic nature is less. Kb value is more, that particular compound having more basic character. Next, relationship between Ka and Kb. See this one, the equilibrium constant for a net reaction obtained after adding two or more reactions equal to the product of equilibrium constants for individual reactions. Suppose a net reaction is obtained by adding 2 or 3 individual reactions, then the equilibrium constant of that net reaction is obtained by the product of equilibrium constants of individual reactions. Here K net, that means equilibrium constant for net reaction, is equal to product of K1 into K2 into K3 so on. That means K1 is the equilibrium constant for one individual reaction, equilibrium constant for another individual reaction. In this way all these individual reactions equilibrium constants are multiplied, then we can get value for equilibrium constant of net reaction. Already this point we completed in characteristics of equilibrium constant. Similarly, see this, similarly In case of conjugate acid base pair, Kw equal to Ka into Kb. We know that Kw means ionic product of water, Ka means ionization constant of weak acid, Kb means ionization constant of weak base. If we take negative logarithm on both these sides, then we can get pKa plus pKb equal to pKw. So pKw means 14. So substitute the value pKa plus pKb equal to 14 at 298 Kelvin. Remember this relation and this one also. Kw equal to Ka into Kb. Okay. Next, di and polybasic acids. See this dibasic acid. If an acid molecule contains two ionizable protons, is called dibasic acid. An acid molecule produces two H plus ions, then it is called dibasic acid. Example H2SO4 and H2SO3. Sulfuric acid and sulfurous acid. Each molecule produces two H plus ions. Next, polybasic or polyprotic acid. If an acid molecule having more than one ionizable proton is called polybasic acid. An acid produces protons more than one. Those are called, that means more than one means either 2, 3, 4, whatever it is. More than one H plus ions are produced from one molecule of the acid. Those are called polybasic or polyprotic acids. Example oxalic acid, formula COOH twice. It can produce two H plus ions, and H2SO4, two H plus ions are produced. H3PO4, phosphoric acid, 3 H plus ions are produced. All these are examples for polyprotic acids. Next, for H2SO4 we have two ionization constants because it can produce two H plus ions. That's why two ionization constants we can get for this acid. See the equation. H2SO4 is a strong acid. It undergoes complete ionization, but this process takes place in two steps. H2SO4 gives rise to H plus HSO4. For this ionization, ionization constant is Ka1. Now this ion again undergoes ionization and produces H plus SO4 2 minus. For this ionization constant Ka2. Here Ka1 equal to first ionization constant of H2SO4, Ka2 equal to second ionization constant of H2SO4. Now, what is the relation between these two, Ka1 and Ka2? Means, see here, higher order ionization constants like Ka2, Ka3 are smaller than the lower order ionization constant Ka1 of a polyprotic acid. Now Ka1 having a particular value, Ka2 another value, Ka3 another value. If we compare the magnitude of all these values, higher order ionization constants order increases, then their magnitude values are decreased. Already we know that Ka value is more, that corresponding compound having more acidic character. Ka value is less, then corresponding compound having less acidic character. Here also Ka1 is greater than Ka2 and Ka2 is greater than Ka3. See the condition, because it is more difficult to remove a positively charged proton from a negative ion due to electrostatic forces. That's why Ka1 value is more than Ka2, which is greater than Ka3, greater than Ka4, so on like that. Say this. This value is more than this value. Reason is, here removing H plus ion from a neutral molecule, then more extent of ionization takes place. That's why corresponding Ka value is also more. Now come to this one. Here from negative ion we want to remove H plus ion. That's why removing H plus ion from this negative ion is difficult. That's why this ionization takes place to small extent. So Ka2 value is less. So in the next step, suppose if we take a tribasic acid like H3PO4, HPO4 minus having undergo ionization and respective ionization constant is called Ka3. that ionization takes place to a very small extent. So Ka3 value is less. In this way, ionization constants order increases, then their value decreases. Okay, so this is the condition Ka1 greater than Ka2 greater than Ka3. Reason is this one. Now see the multiple choice questions. Students, I hope you understood this point. Okay. Carbonic acid H2CO3, a diprotic acid, that means it can produce 2H plus ions, has Ka1 4.0 into 10 power minus 7 and Ka2 7.0 into 10 power minus 11. See these values. It is bigger value than this one. That means in the first step, ionization takes place to more extent than second step. What is the HCO3 minus ion of a concentration of HCO3 minus of 0.025 molar solution of carbonic acid? Already we know that H2CO3, what type of acid? Weak acid. So it undergoes less amount of ionization, less extent of ionization. See the reactions. H2CO3 gives rise to H plus HCO3 minus. Related ionization constant Ka1. In the second step, HCO3 minus undergoes ionization. Then H plus and CO3 2 minus are formed. Related ionization constant Ka2. According to given data, Ka1 greater than Ka2. That means first step undergoes more extent of ionization. Second step undergoes less extent of ionization. So ions produced in equation 1 in this have appreciable concentration. Hence we can neglect alpha with respect to 1. Here alpha is degree of ionization. That degree of ionization is less for second step. First step also less, but comparing to these two steps, for second step alpha value is very less, so we can neglect. So for Ka1, what is the expression? H plus ion, total H plus ion concentration into HCO3 minus ion concentration divided by H2CO3 concentration. So these two ions concentration approximately equal. To small extent ionization takes place and these concentrations are equal. That's why HCO3 minus ion concentration equal to concentration of H plus ion, that equal to Ka into C. See this one. Here Ka1 equal to, in place of this can we write H plus ion, then H plus ion whole square divided by concentration of H2CO3. From this we can get this step. Here given concentration of H2CO3, for this what is the value? 0.025 molar. Now concentration of HCO3, concentration of HCO3 minus HCO3 minus ion equal to H plus ion, that equal to square root of Ka into Ka1 into C. So Ka1 means equilibrium ionization constant 4 into 10 power minus 7 into concentration of H2CO3. Substitute that, we can get this one. So HCO3 minus ion concentration is this one. Okay. So we will meet in the next class.